Energy efficiency is simply getting the same or better service. So that's like the same or better lighting, the same or better heating, the same or better cooking service, but using less energy to do it. It often gets confused with conservation. That is also a strategy. Changing people's behavior is a strategy, but it isn't the same as efficiency. Efficiency is about getting the same or even a better service. We certainly can do better in terms of energy efficiency of our global economy. I mentioned heat engines are part of the challenge. So in our transportation and in our electricity system, using that heat to do work, it's just going to be inherently inefficient. So that's just going to be a challenge. If we can do more in terms of electrification, you can see this little pixel. This is our electrification part of our transportation system compared to the oil. Electrification is already a lot more efficient. And so we can provide that same service with more efficiency and a lot more diversity of resources. Efficiency is great, not just because you're providing that same service with lower energy, you're often saving energy. So there's a lot of promise. There's been a lot of studies on this, on a lot of options that would be, net positive in terms of value um, to the system. It would actually save you money to implement those efficiency systems and lower greenhouse gas emissions and things like that. So it makes sense. Efficiency's challenge is really an implementation challenge of do people know these options? Are they able to implement them? Are things requiring them? Those are where efficiency really meets the road, I would say. We've seen it in the past. This is just using a US example that efficiency can be really powerful. People don't often know how impactful efficiency has really been in terms of lowering what expected energy consumption would have been in the United States, and we can see this in other places as well. In the 70s, a lot of efficiency policies were put in place, and those were really impactful on energy consumption in the United States. So there's this opportunity elsewhere as well. So some of the things that when you're rethinking about how you do things, this is just one of my favorites. This is rethinking how we do piping. So I worked in industry for a long time. I worked for Dow Chemical. I worked in a chlorine production facility. All of our pipes looked like this. They were right angles. They went up and over. The thinking was about, the valve being on the ground, and then you want the pipes to go up high, things like that. So access to it. But doing right angles is kind of the worst when you're thinking about friction and how much pumping power you need to use, right? And so even just doing something, this is something one of my colleagues, Peter Rumsey, does because he does a lot of net zero commercial buildings, is looking at how do you make the pipes more low friction just by having, gradual bends rather than right angles. You do Ys instead of Ts. You can dramatically reduce the pumping power needed. You can reduce the size of the pumping to provide that service. Again, you're getting the same service. You're just thinking about it a little bit differently. And he likes to talk about how, biomimicry here, nature does it so much better, right? And so this is where he's like, this is as good as I get. This is where I would love to get. I'd love to be as good as nature. Obviously, in our blood vessels, we don't have right angles. We have all Ys to make our system pretty efficient. And so these are the kind of solutions that we really think about when we're trying to think about efficiency.